Hello everyone, welcome back to ATPeak AR Open Source Talk Series. Our guest today is Michael Boone. Michael has been passionate about the potential of storytelling, gaming, and the internet to help humans connect from a very young age. This might be why he chose to study computer science, focusing on image analysis, graphics, and AI. Michael has learned a lot from the open source community and is active in the community contributing to different projects. For instance, he developed the North Star OpenVR driver.
So Michael is working on his passion project, Octo. Octo is an open source, cross-platform, cross-device mesh for composable shared world simulations. Michael will give us an overview of it and all this the design consideration, roadmap, future capabilities. I'm super excited about his talk today. Michael, I pass you the microphone and you can start.
Awesome. Thanks for the introduction. Okay, yeah, let's get into it. Well, actually, I think I have slides for that, so just straight into sharing screen. Can you all see that? Okay. How about now? 2 clicks is the key. Okay. Okay, so I am Michael. I have been passionate about kind of augmented reality and people, the ability of games in particular, but also just storytelling in general to bring diverse groups of people together. I think augmented reality is like really a interesting space to experiment with that and push it. Especially as of lately, personally, I've been feeling like the distance of the internet with our technology has not had a great impact on us. But I was trained at UC Davis in computer science. I've had some intense sounding roles, but I don't see them as much. As a graphics engineer in the XR space, for R&D at Pluto VR, which is a company doing telepresence. They're doing really interesting stuff. I actually hope to reach out to them and see if their client can be composed in this simulation space to bring some humans into your space. Then platform team lead at Motiga. It's a game studio, if you're not aware of it, that had one launch title that got a lot of acclaim, but didn't really make it. And then I spent some time doing some prototype multiplayer programming as well as gameplay programming for Turn 10. First, some disclaimers about what I'm about to share. It is intended to be open source. I'm not settled on a specific licensing model yet, but for sure the code will be available to grab, modify, run as you want. But I do, at the end of the day, want to somehow recoup some of the time spent. This is a passion project, but it'd be great to, it's a big project. It'd be great to have some extra oomph to really keep focusing it down. I'm also 12 hours into a booster shot, so I am feeling pretty COVID-y. It couldn't be avoided because I'm heading out to family, and the option was to not be vaccinated or get it now. So please bear with me if I seem a little scatterbrained or slow. I'm going to go over very high level because I still haven't figured out licensing on it, but I am super happy to share details on questions. And I hope that at the end of this talk, you guys will be interested in working together with this tech to make some shared augmented reality. So let's get to it. Why am I doing this? I spent some time in the OpenXR meetings, and just got to know that really well, and the capabilities of 1.0, and where, at least from the information I did have, the team is hoping to focus on for OpenXR 2.0 is really compelling along these lines. I've been actually thinking about kind of distributed AR device cooperation since almost 2010, when I did a SLAM project for Luma Pictures. They were trying to do away with motion tracking and use SLAM to track specific objects in a scene. And I remember coming away from that like, we could do this today. Why aren't we doing this? It would have been really rough, but this has been in the back of my mind. I feel like geo anchor detection is a pretty solved thing at this point. Like every device can do it to some extent. There are various engines and vendors that are like really starting to push like metaverse-y technology and kind of this idea of at least shared VR spaces, as well as they seem to be ramping up for some really interesting consumer-grade hardware with good capabilities for hand tracking, as well as like North Star, which still blows me away as like one of the best AR devices out there to experiment with. And like I said earlier, like iOS and Android, they've been, in my mind, capable of doing a form of this for years now. And maybe it was the edge of the market at that like years ago, but I can't think of anyone I know who has an Android device that wouldn't be able to track the world fairly well. At least who's not over 50. My mom and dad have old phones. And I was spurred to really focus on this by kind of seeing the powers that be seem to push this really centralized model of, we are going to have the metaverse and it's going to be our metaverse. And like, to me, it kind of felt like they were making a VR version of Second Life, or they're talking about it. Like, I don't see how you bridge the gap between a shared augmented reality and a platform specific world. Like if I have an Android device and I can't see iOS worlds, that's not augmented reality to me. And I don't see how that ends up dominating unless we all buy iOS devices, which also seems unlikely. So it just seemed like a good time to really focus on this. And if I didn't pursue it, it had a lesser chance of happening, although probably someone would have done it. Well, when I am describing this to people, I often am met with some confusion about what it actually does. So I wanted to start by like going over what it specifically is not, like what problems does it not solve. So it's not meant to be a metaverse. There's no, fundamentally at the core of the tech is like kind of this decentralized, dilated simulation space. So there's no, the notion that there would be some like authoritative like user like login system for or whatever the versions of the metaverse that we've seen be talked about seems this tech is not particularly good for that, and I also don't think those are very likely to succeed, but that's personal opinion. So it's not a generalized augmented reality engine. I'm not trying to become I'm not trying to replace Unreal or anything. I want to use Unreal. I want to use Unity. I want to use whatever. There's a extension in OpenXR that allows that allows different rendering engines to submit color and depth to the runtime to compose, and I find that extremely tasty for getting some like really digging into this like decentralized simulation space for AR. I think it fits really, really well. And I have been heads down on like kind of the nuts and bolts of this, but I hope to re-engage with Monado when things are a little bit less hectic, and help push some of that forward if Jacob already hasn't, which I've really been heads down, so I'm a little out of touch there. Yeah, it's not supposed to be a platform for AR simulation. I'm not trying to track users. There's no login. There's no way to ban people or ban certain simulations. That's all left up to the consumer. By the consumer, I mean the device that's actually listening to the protocol to figure out if it wants to filter certain simulations or have a registry on its own to figure out that I don't want to talk with these devices or whatever. It's definitely not supposed to solve that space. And it's also not supposed to solve, let's say, an MMO space where you need like really strong assurances about things like money exchanges and things like that. If you were to do something like that with this technology, you would need to augment that technology with external services that actually do the assured transaction that is meaningful to whatever simulation you're trying to do. So hopefully that helps kind of narrow the scope of what these next things are going to be about, because I feel like they're really general. And also feel free to chime in with questions if you have anything specific, or write them down and ask me later. I'm really open to answering any like detailed questions. I on purpose kept these slides vague to kind of let the Q&A session dig into where people would like to. So at a high level, what are its capabilities? It offers foremost like a pluggable protocol. And by a protocol, I mean it has like an actual spec with like a sequencing of events, what required responses there are, what the byte orders are, how simulation should react to certain events and handshakes. It's at the core lock-free, so there's no point where every client needs to agree on something. They can all agree on something as they are aware of it, and there's metadata added to messages that are kind of obscured by the client that do things like take care of lag or kind of determining which event wins in a race condition. Now, again, those aren't meant to be assured lock mechanisms, but they're meant to maintain believability of the simulation that's happening. So it's very much oriented at sharing a space with people around you, not so much like transactions or anything like that. So it's a service-oriented mesh, which means when you discover your peers, there's a couple different unique roles that the peers can advertise as fulfilling. Those roles have their own sets of rules and kind of, I guess, sub-protocols as to how they interact with each other and different components. At any point, you as a peer could self-promote yourself to a role that you think you want to fulfill at that time. And it's all designed to like kind of do that in a graceful way as possible. And again, like not necessarily guarantee a specific event is truth, but make all events believable. There's a couple special roles on it, which I'm going to go into more later. But one of the ones I think is interesting is the shared reality cache. So devices have different capabilities at understanding the world around them. They have different accuracy of that. And the role of a reality cache in this protocol land is to distribute the most accurate high fidelity version of what is stable in the environment to devices that might not have the capabilities to accurately detect it. So kind of organically expand the understanding of the world in a way that you probably couldn't do from a single phone at this point. And it is, at this point, pretty batteries included. There are protocol holes, like I said, for things like what type of anchors you want to choose, but there are default anchors. You could decide that you want to do long-term storage for your state, and you could throw that at a service that's provided that either can put it on a local hard disk or shove it up to Google Cloud into a bucket, or I haven't pursued this yet, but I really want to integrate with IPFS for that type of thing. But you could also just keep this completely on your device and devices you're talking to, and just not worry about persistence. You just want to have a shared simulation with people around you and have it work for the time that you want to have it. And like I said, I'm still determining what specific license I need to actually meet with a specialist there. I'm not the sharpest legal mind. I deal with code, so I've been focused on getting it to this initial state. Now is the time where I feel like I need to meet with someone and figure that out. If you guys have suggestions who have worked in maintaining like kind of community projects and stuff, and what people like, what people don't, I'm super game to hear them, and that would be a huge help. I might have gone into this already. Yeah, I think I covered that in the last slide. That's what I mean by service oriented. Like I said, the basic services are like, there's a gateway service, there's a simulation service, and there's a reality cache. So the gateway's role is to maintain like a hierarchy of gateway peers that I'm calling shards, although I don't know if that really makes sense with their role. That might change. It's a graph between gateway hosts that keep track of neighboring gateway hosts as well as possible child gateway hosts. The protocol for communication between those takes care of things like, let's say I'm a gateway host and my origin is really far from me right now, and I want to update my origin to be closer to what I'm servicing, or I'm hosting some anchors that are now like 300 meters away, and like, why? So I contact some of my peers and say, yo, I got to do away with these. Can you take them? I'm moving over here. That's kind of high level its role, as well as like a simulation discovery, which are attached to anchors in this gateway space. Excuse me, I think I have a little COVID throat. So the simulation protocol, it handles like some initial configuration options, as well as distributing the most recent agreed upon state. And when I say agreed upon state, again, like that's a believable representation of the state to maintain a believable reality. It's not it is deterministic, but it's not, it can't be relied on for things like transactions or anything like that. It's not robust. And then the reality cache, which just keeps track of planes and such, it has some more logic, which I think I have more slides about, so I'm not going to talk about it now. So specifically the gateway service, I'm going to try not to repeat myself. I keep going into these services before I get to the details slide. I already talked about the graph. It also, in a lock-free way, once you are decidedly locked's not the right word, but established in the anchor's purview in the real world, if the anchor decides to move or leaves the area and passes the space you did have off to another host, or you have to take up anchor host because you're the only one left, or you just drop anchor hosting and continue your simulation experience as you want it. It handles all of that under the hood, so that actually from the perspective of someone that's writing a simulation, they don't really have to care about it at all. Like the worst thing that's going to happen is there'll be a callback saying, we have lost the state of the world, redo everything. But there's no like, oh, this just happened, you have to respond to it. This just happened, you have to respond to it. It's very declarative, and here's the reality you need to work with for this event. Do that, and I'll give you the next event. when it happens. I think that's a mistake in the slide. I apologize for that. The second point is irrelevant, though. The simulation part of it's one of the major parts of the role is to add on some like meta information to do things like determine based on connection quality, like would it be reasonable for you as a host to kind of opportunistically simulate this thing, or should you really wait for some of your peers to tell you what's going on? And there's some different metrics for that I'm experimenting with. They have trade-offs, specifically like there's like sorry, the ones that are more eager about allowing a local device to simulate, I think feel better, but they might need to drastically change the state if they got it wrong. So I'm still like kind of playing around in that space to figure out what is the most kind of believable average solution, and allow someone who is writing a specific simulation to determine, you know what, I actually want this. I want to do this, or like, you know what, I don't want to do any of the ones you just supplied. Just give me the raw meta field and I'm going to shove stuff in there. Okay. Reality cache service capabilities. Again, just figure out, you do have to rely on devices self-reporting their awareness, like how accurate their sensors are and stuff like that. But in the current version of the library and services, this is a placeholder. So I haven't explored much with this. I wanted to get the larger concerns as to like feasibility down first. I've managed to get all of those kind of proved out, except for, like I said, I am not 100% on the kind of believable local physics reactions. Like I don't think it's horrible, but it's like not. I want to experiment. So, like from someone who just wants to make some sims, what does it look like? Oh, sorry, that's another slide. This is just overall like devices. So, you do discovery of peers around you. In agreement with the protocol. There's a reference implementation of all of this that you can link against. It's a C++ lib with C functions exposed. And there is a dynamic dependency, but I should be able to get that static. I think more on that when I talk about the demo I was going to make. I think I already talked about all this. Oh, the service components are written in Haskell. The actual library is C++. Haskell has been super fun to work with, and I have some takeaways at the end as to like realistically how did that work out. Was it even really like a save? Is it just different? And I'm kind of on the fence about it, but it was a lot of fun. I already talked about the C++ library with C linkage. I do have the start of an Unreal plugin that kind of tries to mesh some of these client demands more with the kind of how you want to interact with Unreal. At the moment, I am demanding that clients do things that they probably should be encapsulated in the lib, but I made some sacrifices to get to a showable state earlier. None of that is required that the client does it, but like I'd be amiss if I didn't state like that. It's a little bit messy. Right? It's not like there isn't like determinism problems or like sequence problems. It's just I feel like the API of what I'm asking a simulation to actually interact with could be really cleaned up. Looking back after actually plugging it into some stuff. Excuse me. So I keep saying it's composable. Nothing here is composable so far, except for you can have a lot of simulations, I suppose. The basic unit that the library and peers operate on are just a generic like simulation. There's a special simulation that it has some extra details for the gateway component, as well as the reality cache component. But from a library's perspective, it is super happy connecting to as many simulations as your network connection will allow. I do have a spec in the protocol to use also lock-free, the same kind of lock-free stuff I'm using everywhere else, to allow simulations to have like kind of shared aspects of the world that they can emit into and query from. Some examples might be like wind, collision, buoyancy, things like that. I think in particular the world cache is like kind of that, but I'm not using the same kind of problem space for it. And I don't have this. This is another hole, and I want to be sure to point all those out, because I do hope that you guys will reach out and want to start using this. So it'd be crazy if it wasn't as described. The library, so there are plans to allow a specific engine. So let's say you Unreal is like, I can actually do accelerated physics, and I don't want to rely on simulations to do that. Why don't you send those channels to me, and I will respect the reference space and all that stuff. So does it work? Yes, but yes, but I ran into a huge problem. Well, it's not a huge problem. I feel I got like egg on my face from this. I wanted to have a demo today, which I'm hoping to record after this talk and get added onto it, of a chess game behind me on a table with the North Star, and I had a native client with like an inverse green screen going on this webcam. But I went to link in the updated version of this lib, and for whatever reason, the way I formed it, Microsoft Visual Studio's compiler is very upset with me. It's not like warnings, it's failing at link time, and I really have to dig at it more. To be honest, I've done most of my like that level of like digging in like Unix systems, so I'm a little out of water there. If anyone has experience digging into that on Windows, I would also love to talk to them about that. But that ended up killing the demo I was hoping to give during this talk. I have the initial peer discovery, like the handshake right now is kind of mocked out, because I'm again really focused on like the believability of the real-time events, and kind of that area to me is more interesting at the state. Like discovering peers around you is I feel like a solved problem. So I'm not too worried about that. I already talked about the lag compensation. I want to work on it more. It's a work in progress. So that's kind of what to expect if you were to want to start working with it. This is just like I thought it'd be useful to show like kind of what it asks a simulation to do. I left off some details here, but like overall, you generate some callbacks for the service to interact with you. It's going to go off and create a number of threads and go do its own thing. Config and then kick it off. Wait for it to have established things or timed out to like a necessary host or like it's a pivot point where it's like, do you want to be this host? Like what's going on there? And you start interacting with it. There's stuff to say you have local tracking, you lost local tracking, where are the anchors around me? What format are they? I have identified this anchor, and this is its relative position to me. Enter me into this gateway, and then from there, show me the simulations, and I'm going to join this one. So it's kind of like you prepare some callbacks, and that's the part that I said could be cleaned up, where the callbacks for the host right now demand the host to keep track of a number of subthreads. And looking back on it after wrapping up like the last feature, I could clean that up. I don't know if I bring this up in another slide, so I'm just going to go into it. From the simulations perspective, it gets events. The events have an opaque tag to it, and that this type of method is used a lot throughout the different components, where the tag is opaque, but it is on the simulation to provide that tag on anything that is derivative of whatever information it said. So it kind of hides a lot of the nitty gritty in the library. It was a trade-off between like, I feel like it's simpler. I guess I'll have to see as it gets more, as I mess with it more, I guess. But like hiding that detail at least keeps a client from having to worry so much about details of what Octo is doing under the hood. There is a potential there for a mix-up where the client will send an incorrect tag on every case that could be determined there. It results in an error, and the library discovers there's nothing to necessarily guard against a malicious client just going crazy with tokens. So there's guardrails, but there's you can poke through them if you really wanted to. And that would result in like a kind of an unstable simulation state that hopefully the peers would detect and be like, hey, this guy's crazy. We're not going to go with that one. So what does it look like to actually set up a local development if you were to want to do that? The current stuff has Terraform for written against Google Kubernetes engine and GCE in general. It has a set of Haskell-based services that are Dockerized and are set to deploy via Helm charts to either a Kubernetes cluster or a Minikube locally, or you could just run them in Docker containers, or you could run them locally if you really wanted to do that. Since the library itself has like all this stuff in it, it's really big, which is complicated to mess with, but it also lets you completely mock out services if you want to do like local development. Let's say you have like people going down different paths on different features in like a game or something. You could toggle on the self pass through and be completely independent of any like shared infrastructure while iterating on that. Of course, that's not going to simulate lag or anything like that, but I think that aspect is useful for productivity and definitely helps. Oh, they do all the right metadata tagging, but there's no lag, so I wouldn't rely on a local pass-through client to really vet if you're doing like something where you might have very different events coming in from different clients because you decided to do your own kind of logic there. Oh, sorry, I'm feeling pretty. Okay, I was going to do the live demo here. However, like I said, I ran into that linking error. Really caught me off guard. It's a simple library. The details of what's going wrong is everything's kind of formed around 0MQ, and then for the prototypes and stuff like that, the actual implementation of how you store your events or whatever, that the protocol doesn't care about that. I've been using message pack to do that, but you could use whatever you want. You could send raw bits over if you want to care about host byte order and stuff like that. But like I said, I ran into that linking error where for whatever reason, the newer version of the library, when I took it back to Windows, has cannot define, there's a templated 0MQ function that for some reason can't resolve. I've run into this once before when I was messing with like LLVM rock. I'm not convinced I know why yet. So I ran into this yesterday at 11. I was like, okay, let's push through it. And then 10 a.m. I was still butting my heads with it and got some sleep because the booster really knocked me out at that point. But I hope to patch that up and append a live demo of that chess game here. Here's like a visual overview of what a setup might look like. Say you have a North Star head, some using a North Star headset over here. Oh, shouldn't have clicked. Some real sense sensors in the room. I guess attached to Raspberry Pi or something that can communicate. Some perhaps robot that would like to understand the shared space. And they're all like, so there's two simulations in this example. The Android device hosting one. There's a persistent service off the cloud host in the other. iOS is the gateway, and the blue lines kind of represent passive communication between them. These communication paths are not flooded with data. They're pretty low frequency messaging. It's fairly event based. And that's kind of what a mesh topology would look like for this scenario in the room. I guess another thing to note is you could potentially, if you were interested, use just the gateway portion of it, and at the point that they're all in the shared local space, actually shift them off to like some traditional Unreal server if that's what you want to do, and manage your own like creation and lifecycle of that service and paying for hosting, all that stuff. I mentioned that because I was talking with another engineer who was interested in that. I didn't think about it because I'm more focused on the kind of meshed, localized simulation aspects of it. All right, so what's reasonably going to be available first to mess with if you want to? The UE4 plugin is pretty far along. The Windows native and Windows XR and Linux native. The Windows native has that linking issue, but it's not far. That just really caught me off guard. I didn't expect a standard CLib to have linking problems. I'm really curious what that ends up being, but I think it's going to take getting really up close and comfy with Visual Studio's developer command line tools, which I going to take a while, or a day at least. Unknown problems are hard to estimate. And then the Haskell-based persistent service solutions are all available, and like I said, Dockerized. Okay, so how am I doing on time? Oh, not too bad. I was worried I'd be really quick here because I'm not doing the demo. Maybe it's the COVID saved me. So when and how can you get your hands on it? Like I said, it's not licensed yet, but if you're willing to sign some paperwork, I'm happy to send the code over to you, share it with you. I would like to be around so that I can really like, if you run into something, you can just reach out to me and I'll be there. I can't do that because over the next couple weeks because I'm going on a family trip. But please reach out if you're interested in that, and when I'm back, we'll work something out. I'm aiming next year to have it actually open sourced. Hopefully some managed hosting solutions if you just want to like click a button and start having some persistent simulations around your area. Okay, so what went well so far? I was honestly, when I started it, a little concerned about some of the technical risks, but I haven't run into any major blocks. And the further I get into it, the more confident and assured I am that like this is not going to nothing's going to come up that's like, oh, never mind. Like it's pretty proved out at this point. I did decide to do the prototype stuff in Haskell. The idea behind that was that it would be easier to iterate on. And I was also really kind of worried about, I wanted to make sure that I had to work hard to have some shared state in there because this should all be lockless. And it actually worked out really well. I think the types of solutions I've come up to with this lock-free stuff would not have been landed on without working in that pure functional land. Not that they couldn't have been not working in it, but one of the bad things about that is that it is like such a different coding space than C++ that when it is time to like take an experimentation and bring it into the library, it is a lot of work. It's very different. It like I go back and forth between being amazed at how concise Haskell code is and nice it is, and then how much control C++ gives you. I don't think it's been an overall win or loss either way. It definitely wasn't a mistake to do that in Haskell. I think it's definitely not as friendly to anyone who wants to use it because you guys all got to work in Haskell, but it's dumb Haskell. It's like I'm not doing very fancy stuff. Like I'm keeping it simple. A couple monads, no transformers, a transformer in one thing, but like, I don't think it's scary, but you guys tell me. What's going poorly is it's taken a long time too. Because I do the prototype in Haskell, I have to move it out into C++. Also, I had this, I've always worked on C++ projects in Windows first and brought them over to other OSs. And that's really smooth. But this one, I worked in Linux first and brought it back to Windows. And even though I'm like coding against the standard lib and I am like keeping away from undefined behavior, there's always just something weird about trying to get it to be happy in Visual Studio land after some time in Clang or GCC. It seems like Clang and GCC are much more coherent on what they'll accept in different standards. I just didn't. I'd always gone from Windows to either stayed on Windows or gone from Windows to Xbox or Windows. I'd gone from Windows to Linux, so that caught me off guard and kind of assumed code against std C17 and it'll be fine, but no. And that wraps it. If there's please, if you are interested in doing some stuff with this, reach out to me. If you're willing to sign some paperwork, I can get I'm happy to send these libraries over to you. I think it's best to wait until after the holidays because I'm not going to be around I'm going to be like flying in Hawaii and stuff, and I have no clue what that looks like. I'm probably going to pass out after this because I have a booster shot kicking in right now. But hopefully there'll be a fast follow-up to this with that chess demo I'm talking about so you guys can see it in action. Yeah, well, I guess I'm ready for questions or feedback or interest, or I'll leave that slide up a little bit longer if anybody wants the email address at the bottom to reach out. And I think I'm ready for Q&A.
Yeah. Michael, that was awesome. Thank you very much for sharing all the, sorry, the presentation and the information about Octo. There are a couple of questions from Alex, not me, but another Alex. So I would like to. I'm gonna read it to you. It's about it's more it's a long question. So it says by the sounds of it, Otoy wants to solve persistent state. They discuss wanting to implement that onto Solana blockchain. and for TPS speed, and the VM can run Rust and or C code. Have you considered using blockchain tech to keep it decentralized? Um, or interesting choices are Theta and Holochain. That's
I've kind of steered away from blockchain because I was excited about when I first heard about it. I looked into more NFTs. I thought were like kind of weird, and I have like there's nothing stopping someone from wanting to store state on the blockchain if that's what you want to do with this tool. The actual events and state are transparent blobs, so a simulation could do whatever it wants with that. You could also change that particular hole in the protocol where it saves the persistent state possibly to a bucket to interact with blockchain tech. But I've been kind of down on blockchain because I just it feels like it's wasting a lot of resources and energy, and I don't see anything good coming from it. So I guess I've got some barriers to. I'm not like closed off about it, and I wouldn't have control over if you want to do that anyway. But that's not something I've really considered.
And then I want to I have a questions about when you talk about simulations and you talk about um, well the you said something about people can follow some the idea of following and being followed following a simulation or being a follower of a simulation. You at one point you said something about if there is simulations where there there's certain events that they look like crazy and you don't want to follow them. Can you elaborate a bit more on that?
Yeah. That's part of like the part I'm talking about with lag compensation and like event uh like event determining like kind of racing events. I I would hope that there to have a good kind of detection mechanism for that if there is some like big movement where a client could say this is suspicious, I'm not going to simulate this. And if all the clients kind of have the same idea of what they will and will not tolerate in those realms, um, you'll end up with the most believable version of whatever event was attempted to be sent when those clients communicate back with the sim host. So for taking snapshots of state, there's like a round robin type thing between all the clients that it's like it's a opaque binary blob, but it's got extra stuff hashed onto it around that. Like one to determine unique local layouts, like if the simulation changed its local space in between when this, like what the most recent event this client had received, and also like the extra meta information with that event. So I would hope to resolve that there, but that is like I think are like just the nature of like this approach. It's a risk where if you had a bad actor, you need to figure out how to deal with that. And I think clients have enough information to really make that determination because they'll know their simulation space. I don't want to get into the realm of trying to guarantee exact ordering of events because it limits kind of the lock free and the ability to really decentralize it. So I think that's personally I think that risk is not as bad as it might seem. Like I said, you wouldn't want to do this for an MMO where someone could be malicious and decide I have 1 million gold right now. It's kind of the tech space is more around. I want to play an RTS in this room. I want to play it with someone who has an Android device. I want to play chess. I want to have a art piece on my wall. I want to decorate my apartment with lanterns, or I want to leave a picture on the wall somewhere, or like that kind of thing. Less so for like overarching um, MMO style stuff. So that either made people really hesitant about it, or it's fine.
Yeah. Oh, okay. Yeah. Like it's yeah. I mean, now it's more clear. I'm definitely we definitely when we do a edit with the demo at one point we probably get more questions on the demo, and so I think it will be yeah. I think that time I think it be better. So yeah, so Michael, I would like to thank you again for presenting us Octo. I think it's we can conclude for today the presentation.
Yeah, thank you very much, Michael, for being here today, especially under the circumstances. I hope you feel well soon, very soon.
Thanks for having me, and I hope that was interesting to some of the folks listening.
Thank you. And next Tuesday, December 14, our guest will be Sachin Guruswamy from Luxonis, talking about their depth AI sensor. And we would like to thank our partners for their support in this first open source AR talk series. And if you'd like more information on ATPeak and the lineup we had of open source AR talk series, visit our website, atpeak.io. Don't forget to check the AR talk series playlist and watch the other talks in the series you might have missed.